Splash provides powerful tools for intersection design. One of the tools for intersection design is a three-dimensional fillet child. Now let's take a look at some fillets, see what we're talking about. Here, if we window up on this side street, we see that we have turnouts with sidewalks coming in and dead ending into the fillet. Here, at the other end of the street, we have an intersection with no fillets, with no radiuses. They're filleted, but there's no radius. And here, we have an odd-looking turnout that turns out around a widening road. Let's see what happens if we change some of our geometry around. These are, as I say, three-dimensional, and they are dynamic. So I'm going to select this building. In this example model, the building is controlling where the widening occurs. So as I say, you see that the side street comes in, the fillet comes, turns all the way around to join a reverse curve widening of the road. So we'll drag the building away, and we see that we have now we have a normal intersection, normal looking intersection, and the widening of the pavement is far away from the intersection. As we bring the pavement, the building, which causes the pavement widening, as we bring it closer to the intersection, we see that it affects the fillets. So we'll move it to here, and we have just a normal widening. If we get it to influence the turnout, we start to see a little bit of the turnout. Let's try one more time. And now we see more of the strange geometry, not strange, but complex geometry that we saw earlier. Let's go back and look at this intersection. We'll select this alignment, side street, and we'll move the PI. So let's move the PI. What I want you to focus on is not only do the fillets correct themselves, but the sidewalks correct themselves as well. So we'll put it right here. Now as Ripple-Thru recomputes everything, we see that our sidewalks correct themselves. Now, what I'd like to do is to demonstrate how we actually create these fillets. Here we're looking at a relatively simple set of alignments. We have a main street with two edges of pavement, and we have a side street with two edges of pavement. Now, just so you realize there's three-dimensional information here, this is the boundary of our 10. So we're out here on a 10, and there's vertical designs on all this geometry. You can take a look at the simple road design demonstration to see how roads are designed. So we're to this point. Now, what I'd like to do is window up on the intersection, and you see our edges of pavement just plow right on into the intersection. So let's use our fillet tool. Now, this is the fillet tool, and I'd like to use a 25-foot radius, and I'll put in a clockwise fillet. Now, for a name, we'll let it be EP, for edge of pavement. Now, this is important, the percent of arc for warp location. Now, this is going to vertically start tangent. Well, we're going to go clockwise, so it'll start here and go this way. It's going to vertically start tangent to this edge of pavement and vertically spline until it's tangent to this intersection. However, that's not enough in road design. So it's also going to take a look at the cross slope, project the cross slopes until it, and then average those two cross slopes to keep the water off these roads. Now, we'll explain a little more about that in a minute. Let's just demonstrate the tool. So this is, we want to start our fillet here and measure our cross slope from this alignment. We want to come to here and measure our cross slope from this alignment. We'd like our radius to be in this quadrant. So now what we're looking at, these are simply the tangents being displayed for this road. So what we're let's also go ahead and put one in here while we're here. So we want to go from here, this is cross slope, here, this is cross slope. We want to be in this corner, in this quadrant. Okay. Now, so we have our fillets in place and they will ripple. Now we want to clean the intersection up. So we'll use this cleanup tool, and we want to keep that, and that, and this, and this, and let's select this alignment just so you can see clean geometry without any tangents being displayed. And here's our intersection here. So if we move this PI, the intersection will fix itself. And there's the power of ripple-through. Okay, what we're seeing is this is the edge of pavement as it comes through the intersection of the main street. This is the shape of the fillet superimposed where it came into, it came out tangent to the edge of pavement of the main street and warped and transformed itself to drop its water off onto the side street. And likewise, this is the other turnout on the other side of the street.